Today we are going to talk about distributive property. Distributive property is a mathematical property used to rewrite expressions involving addition and multiplication. That's what the definition says. However, it's here mentioned only addition. It can be also a subtraction, but because every subtraction can be rewritten as addition of the opposite, that's why the definition does not mention subtraction. So if you do have in parentheses adding or subtracting of two numbers, and here we have those numbers represented by different letters, and then we are multiplying that by a number that is outside, a factor, then we actually, instead of adding the numbers inside first, we can actually multiply each number inside with that number from outside. So here is that's how that looks. So if we have example with numbers, so if we have 5 times 4 plus 6 in parentheses, normally by using order of operation we would add 4 and 6 first and then multiply that result by 5. Now instead of doing that, we can actually multiply 5 times 4, then carry the addition sign after that, and then multiply 5 by 6. And we should get the same result by doing that instead of following order of operations. So let's see that example. So if we have the same expression here that we want to evaluate by order of operation or by distributive property, here is how we do that. So by order of operations, we would do 4 plus 2 first, which would be 6, and we would then have 5 times 6. Now with distributive property, we would take 5 times 4, carry the addition sign, and then 5 times 2. Now the next step with order of operation would be multiply 5 and 6, which would give us 30. With distributive property, we would have to solve multiplication first. 5 times 4 is 20, carry plus, 5 times 2 is 10. And you can notice here, 20 plus 10 would give us 30. So it does not matter which way we are doing it, we still can get the same answer. Now, today we are going to explore how do we evaluate just using distributive property, not following the regular order of operation. So let's look at a few examples. Here we have 5 times 4 plus 2. We will actually multiply by 4 both of those numbers first. So 4 times 5, carry plus, and then 4 times 2. Now we do the multiplication. 4 times 5 is 20, plus 4 times 2 is 8. Add them up, we have 28. Next example, we have 3 times 3 plus 7. Again, instead of solving parentheses, we will multiply 3 by 3, carry plus sign, and then multiply 3 by 7. Now we solve multiplications. 3 times 3, 9, plus 3 times 7, 21. Add them up, we have 30. Let's look at this one. 7 times negative 3 plus 5. So we are multiplying 7 times negative 3 first, carry plus, and then 7 times 5. Multiply, we have negative 21 plus 35, which will give us 14. Here is the last example of these type of problems. Now notice here, we have in parentheses negative 3 minus negative 4. First of all, we can change this and rewrite as negative 3 plus positive 4. But let's deal with it as subtraction. So we multiply 2 times negative 3 first. Then we carry minus sign. And then we multiply 2 times negative 4. Now when we simplify this, 2 times negative 3 will give us negative 6. And then minus 2 times negative 4 will give us negative 8. Negative 6 minus negative 8 is the same as negative 6 plus 8. And we have 2 as a final answer. Now, if we rewrote this as addition of opposite, we would have negative 3 plus 4. And then we would multiply each one by 2. We would still get the same answer. The same way, we can use distributive property to rewrite expressions with parentheses, with operation within parentheses. We can do the same thing when we can use distributive property to write out a common factor, to take it out. So here, look at what I'm talking about. I have here 5 times 4 plus 2 times 4. So notice that both parts of this sum have multiplication by 4, because 4 is the common factor being used to multiply both 5 and 2. I can take it out, and then I leave 5 plus 2 inside of the parentheses. So I'm just going in opposite direction. So here is the other one. So we have 2 times 3 minus 7 times 3. So what factor is being used in both cases? What number is being used to multiply both 2 and 7? It's 3. 3 is being repeated. So I can actually take that 3 out and leave 2 minus 7 inside. The last one, negative 4 times 2 minus negative 4 times 5. So think about what is multiplying both times. It's actually negative 4. Negative 4 is the common factor. So I take it out and I leave 2 minus 5 inside the parentheses. Now we can also look at area model. When we talk about distributive property, this can be a visual way of seeing how those two expressions are kind of equal to each other. So let's look at this big rectangle, and we want to write expressions for finding the area of that big rectangle. We can do it two ways. We can first look at each rectangle separately. So I can find the area of this rectangle, which I would then have 3 times 8, and then find the area of this rectangle, which would still be 3, and then times 4. And here we are, 3 times 8 plus 3 times 4. And we would then find this is 24 plus 12, which would give us 36 units, square units. Now, but the other way I can do it, I can actually find how long is the length of that whole rectangle, which I would find by adding 8 and 4, and then multiply that by the height. And in that case, I would get the same thing. So 8 plus 4 would be 12, times 3 would still give us 36, the same area.